Hello, and welcome to another session of Salesforce Epic Hours. My name is Robin, and today we'll be talking about the design patterns for Salesforce test automation. Thanks to Apex Hours for giving me this opportunity to share the knowledge with our Salesforce Ohana. So without further ado, let's get going. First, a brief introduction about me. As I said, my name is Robin. I'm the Vice President of Technology and Product at Provar, heading the test automation apps. I have close to 15 years experience working all the way from a tester to engineering and now product and engineering leadership across various domains and organizations and startups. I'm a national speaker at conferences such as Dreamforce, TDX, and Stadium Conference, and I have authored courses and books. I also contribute to open source, and I'm a mom, a manager of managers at office, and a dad at home. You can find more boring details about me at my website, robin-gupta.com, or you can also scan the QR code. Here's a brief agenda of today's discussion. We'll look at today's topic, we'll slice and dice it. Then we will understand what does quality mean, various frameworks, visualizations for it, like the test automation pyramid. And then we'll go through each layer of the test automation pyramid to understand what design patterns can be applied for the unit testing layer, integration testing layer, and further down the road, the UI testing layer. We'll also share some takeaways and resources. Stick with us till the end. First, today's topic, design patterns for Salesforce test automation. Design is about creating, executing, or imagining a way of doing things. Patterns are repeatable frameworks, and in this case, these are the patterns which I have observed during my tenure in the industry. You would agree with some, you could disagree with some, but that is one of the key learnings we look at the end, that it depends on the use case which pattern we apply. Salesforce, as we know, is the #1 CRM in the world, and test automation is the process of automating the same repeatable checks. So that's today's topic. And moving forward, before we go into test automation, first let's understand testing and quality a little bit. So what is quality again? Here is a very simple representation of how to envision quality. So we as software delivery teams generally make some assumptions when we are doing software delivery, when we are crafting the software for our end users. But when we deliver it to them, the user generally has some expectations from that software. The intersection of these assumptions and the user's expectation is where the real quality lies. We might assume 100 things, and the user might expect 110 things. So those 10 things in common in between, or maybe different, is where the real quality for the user lies. Giving examples, we might assume that the user would appreciate a high fidelity camera, and the user might expect not just a high fidelity camera, but also a microphone embedded. So is this a requirements gap? Is this a development gap? Or is this a quality gap? That is how we can look at quality from one angle. Obviously, there will be multiple angles to look at quality in the SDLC. There are multiple events which can impact quality. As we were discussing, there could be internal scenarios like features, stories, and bugs which you deliver. So we might consider users' expectations, or we might not, and therefore the bugs could arise. There are external scenarios which impact quality. Some of them could be from, let's say, the Salesforce ecosystem upgrade. Maybe a certain release could be patchy or buggy and could impact the quality or the user's experience. Similarly, there could be integrations or partner updates which could impact quality. In one of my cases, we had to work with a search engine implemented for Salesforce, and we had to work in lockstep with how they were implementing the search algorithm so as to ensure the best quality of experience for our users. Last but not the least, a topic which we all adore, hopefully, are technical updates and frontiers like generative AI. We have to be super mindful about what kind of technologies are out there which can improve or which can also decrease the quality of our delivery. Last but not the least would be salary, but I'm just kidding over there. It could impact quality, it should not. Now, how to automate these checks over time is where automation and these feedback loops come in the picture. So, as we saw earlier, the overlap of assumption and expectation as the part of software delivery is where real quality lies. And we can implement some feedback loops from the expectation back to the assumption. And then the automation of that is where test automation can improve the quality of our delivery process. For example, across the whole delivery pipeline for release one, we assume some things and deliver it for the user. Hopefully, the user expects the same and maybe some more, so that some more can be captured and pushed back as feedback into our assumptions. Now, over release 2 and 3 and 4, as we go through delivering our software and experiences for the user, we can automate these checks so that no human on the team has to go and check for that missing quality again and again. That is where test automation can help us be more efficient and effective in delivering quality for our users. So, how should we think about implementing these frameworks? To our help, there are many visualizations in the industry for software testing and automation. We'll present two of these and then we'll use one of them to go through our journey and look at the various design patterns. So the first one over here is the Agile Testing Quadrant. All credits to Brian and Lisa. Now, if we look closely, this quadrant has four axes: business facing, technology facing, guiding development, and creating product. And then based on them, there are four quadrants for delivering quality and product for our users. So the first quadrant is all about unit testing and component testing. Quadrant 2 is about story acceptance tests or UX tests. Quadrant 3 is about exploratory testing. And quadrant 4 are more about the non-functional aspects, for example, performance and security. We're not saying that this is the only way to go about it, but this is definitely a very strong mental model to assess the quality of our delivered product. There is the other one, which is very famous and have been in the industry for a while, the test automation pyramid. It has various layers, all the way ranging from unit tests to component tests to integration, API, and end-to-end UI test cases. At the top, we also have a small cloud and we have the word performance, highlighting that we could have non-functional tests at the top. Now, if we look at these layers, we can see that we should ideally have the most number of unit tests, some API component tests, and then a few UI tests. And there are three measures or three criteria which help us move across the pyramid. So the first one is cost. Unit tests are very cheap, but as we go up, the tests become costlier in terms of time, investment, and obviously dollars. The second is the solidness of these tests. Unit tests are pretty solid, but as we go up the pyramid, these tests start becoming a little brittle and flaky. For example, when we write the unit tests in our code, they could be really solid. And as we go up the pyramid, the UI tests could be a little brittle, could be a little flaky, depending on the UI of the application. And last but not the least, unit tests are really fast. We have a small rocket sign. And as we go up the automation pyramid, the UI tests tend to get slower in comparison to the API tests or to the unit tests. So we use this as a reference for understanding the design patterns for Salesforce test automation. So let's look at each of these layers in a simple way. Here's the same pyramid, but with only three layers. Given our time together, we'll look at each one of these with a few examples. So the first and foremost is the unit test layer. The design pattern we'll explore over here is the singleton design pattern. Now, as we all know, singleton design pattern or singletons are class which have a certain purpose, can be only initialized only once. So in this case, let's say we have the client calls coming into the controller, and from there we can get the instance of this singleton for the first class, second class. But what we do for the test automation at unit layer is that we do the singleton and we do a stub class, so that we don't have to hit the first class, second class, and the other classes downstream again and again. In very simple terms, for example, we try to get the date time instance. Now, rather than trying to get it again and again and only having the positive test for it, we could stub it and check for a leap year with some fake test data. This same rhetoric or logic can also be applied to other applications, such as the first class could be something which provides us the account details. But rather than providing the real account details, we can provide the stubbed class to give the fake account details or test data. So let's take a look at the code example for it. So here we are on the developer console on our Salesforce instance to understand the singleton design pattern using the datetime provider example that we were discussing earlier. So the first one is the singleton controller, where we can see that we are getting an instance of the datetime provider. The datetime provider is the railroad switch over here. So it gets the instance and then checks is it a leap year and gets the now time value. If it is a leap year, prints yep, get testing, else enjoy a free time. So once in 4 years, it gets to testing, and then the other time it enjoys a free time. Jokes aside, here is the date time provider implementation, which is the railroad switch or the singleton, which helps us do the stubbing for our testing purposes. As we can see, it is nothing magical. It checks if there is the instance is null and then gets the new instance, and then also has a method for returning the date time for that particular instant. Here is the test for tying these pieces together. The text fixture is very simple. The first test is not stubbed out, so that provides the current date time. And then the other one is stubbed out, wherein we pass a value for a leap year. So we are doing this test in 2024, and we'll get the real instant, and we'll also get the stubbed out values for 2020. So let's run this and see what happens. So when we run this, the test runs, and then through the logs, we can see that it gets the value not only for the current date time, but then it also checks for the 2020 value that we had given and says get testing for that particular value. Coming back to our presentation, that is how the singleton design pattern is a great example of design pattern for Salesforce test automation at the unit testing layer. Now the singleton design pattern is detailed up over here. And while datetime provider was just an example, the same piece could be applied for stubbing or mocking other pieces of our implementation. In addition to the singleton design pattern, there are various other design patterns in unit test automation, such as dummies, stubs, spies, mocks, and fake. The idea here is very simple. We should not be toying with real data or real endpoints. We can stub them out, or we can also have that railroad switch for a sub-implementation for our testing purposes. Moving forward from that, let's do a quick sleepiness check and see whether you are awake and going through this content or feeling a bit drowsy. Is this a unit test or integration test? What we're trying to do over here is that we are trying to insert a new case with a certain origin and status. When I actually joined the Salesforce ecosystem, I felt, yeah, this looks like a unit test. But is it really? Or maybe it's an integration test because it takes the values from your local and then actually inserts them into the Salesforce backend with certain details and fields such as the origin and the status. And in that journey crosses multiple layers of code integrations and therefore it's an integration test. So, maybe it's an integration test. Jokes aside, you can decide that. But that being said, let's move on to our next layer of integration tests. So for the integration tests, we look at the decorator pattern for API test automation. The image credits here go to refactoring guru. Let's say we have a developer who's feeling really cold in the winters. If we provide them with a sweater or a jacket, they can survive that winter. And if we provide them with a raincoat and maybe an umbrella, they can survive the rain as well. How does it relate to integration testing and design patterns? So decorator pattern implies that we decorate a core class or piece of code with some extra annotations, functionalities, so that it can perform under various conditions. Just like the same developer who is feeling cold in some conditions can be supplemented or decorated with extra capabilities. And then with those superpowers, they can survive the winter or the rain and other places. Let's take an example and it will make things a lot more clearer. So we'll go to our IDE where we have tried to implement the decorator pattern for API test automation. Yes, I know I'm a little old school for using Eclipse, but on Saturdays and Sundays, that's my place to be. Okay, so here what we are doing is we are trying to create an account using APIs. We provide the string URI, JSON object for account data, and with some payload. Now, while we can run this, the interesting part lies in the HTTP client wrapper, which is nothing fancy. It's a wrapper on top of the HTTP client library in Java. We have taken the core methods, implemented a class, and then decorated it with extra capabilities. What are these extra capabilities? In our case, they are very simple as logging statements. So we are just saying when you do the login post, the headers are here for debugging purposes. And if an error happens, we can do a small try catch to handle the errors. So we have taken the HTTP client Java class, implemented it with our code, and decorated it with logging or debugging statements. So when we run this, we can see that if something fails, we can not only catch the exception, we can also print out its details. So that is how we have implemented the decorator pattern for integration layer or API test automation. Going back to our presentation, here is a small cutout code example for the decorator pattern. As we can see, we have only decorated it with system out println, which is not recommended in production code. It is here only for reference purposes. But in production, we can actually decorate our classes or code with extra debugging, logging, traceability mechanisms. And rather than doing something as simple as system out println, we can also have advanced logging capabilities using log4j or some other libraries like SL4j. We could even parse the logging data to applications such as Grafana and Prometheus and visualize them on a dashboard. And that is how we can decorate the code to give it extra capabilities and enhance the software delivery production process. Moving forward, the last but not the least is the UI layer, the one closest to my heart. So on the UI layer, there are various design patterns. The two that we will discuss over here are, one is page factory and the second is screenplay pattern. The images are provided by AI. And if you don't want to deal with all these design patterns, you could also use Provar for test automation. Now, the first and foremost, page factory design pattern. Here we have the login page, which we have seen many a times for our portal of Salesforce. Now, the page factory design pattern suggests that we can emulate or we can model every web page on a website. And furthermore, maybe the different components on a web page or the website into page objects so as to maximize reuse and also enhance the stability of the code base. How does it do it? It's very simple. For example, on this section, we see the username, password, login button, and the other web elements for the user to interact with. Now, in UI test automation, when we use libraries like Selenium or Playwright, we need to implement something called a locator, which is like a GPS coordinate of a web element on the screen. For humans, we can see these elements through our eyes and we can interact with them. But for softwares like Selenium or other test automation providers, they need to have something called a locator so that they can locate that web element on the screen and then interact with it. There are many ways to implement the locator. You could write the IDs, you could also write the XPath. Basically, it can use those XPaths to go through the HTML and then interact with those web elements. Now, all these web elements on a certain page can be written as web elements for the page object as variables. And then also we can implement the methods relevant to that web page. For example, this is the login web page. So we can have the method for login implemented using those web elements and locators and the Selenium code base. But why should we do this? Isn't it making it very complicated? Interestingly, the page factory design pattern, just like a factory manufactures multiple instances of the same design, similarly, the page factory helps us reuse the same code across our test cases. Imagine we had 100 test cases on our Salesforce instance, and all of them would begin with the same starting point of logging in into Salesforce. Wouldn't it be tedious if we had to write the same locators and the same login method in 100 places? So based on the page factory design pattern, what we do is that we generally write it in one place and then reuse those same across our test cases for maximum reusability. Also, if some web element, some XPath, some variable changes, we change it in one place, and then the same value automatically gets changed across our code base so that our tests are more stable. Let's take a look at this on the code base. So we'll go back here and we have a small test to log in and perform some operations like creating an account on our Salesforce instance. The Lightning login page is an object of the class Lightning login page, which is the page object for the login. Now, as we saw on the snapshot, at the top, we have the variables defined for the XPath and locators. And then down below, we have the method for logging in into Salesforce. Nothing super complicated. This is all Selenium code so that we could wait for certain elements to be present on the screen. And then we send the user ID password and then actually click on the login button. Now, since we have defined this in one place, if we have 100 test cases for creating accounts, opportunities, leads, so on and so forth, we can use the instance of this page object in all those places. And if we had to do any changes, we can do those changes in one place, and then they would be parsed through all those test cases. So that is how the page factory design pattern helps us maximize reusability and stability for the code base. The second design pattern for UI test automation is the Screenplay pattern. Now, this is a slightly different paradigm as compared to the page factory design pattern. Here, we have an actor who performs an action composed of a few tasks on a certain screen. Just like an actor, as part of a screenplay, would perform some actions on the stage. So this provides a very good readability to the test case and also breaks the complications of UI test automation into very small fragments which can be optimized as per the use case. How to go about it is very simple. Here's a small code example. Here, as we can read easily, it says open the browser and navigate to a certain URL. From there, log in as admin with the credentials, and then assert that the search is displayed or certain web element is displayed. When we look at the same example from the code base, here is what we can see. The same example has been implemented using Selenium. Open browser has the navigate method. And as we can see, not only is it very readable for non-technical users, it is also highly customizable, where each element can be customized as per the needs of the test automation use case. So open browser can not only have navigate method, it could also have back, pause, close, and cancel, just like how we would do with the browser. Similarly, when we do login as, the login could be as a certain user. It could also have waits and some other critical methods for performing UI actions like clicking. And if we go further, the last but not the least is the assert, and we can further customize the assert too. The one over here is from TestNG, a testing library for Java, but the same rhetoric of applying screenplay or breaking the large complicated action into smaller chunks can be applied to the assertions as well. So that is how we can implement the screenplay pattern for UI test automation. But where should all of this run? So a quick note around environments. So as we can see, the columns are around the various environments. We can provision Scratch org, developer, dev pro, partial, and full copy. And then the rows are across the various kinds of tests that we can perform. So build and unit tests perform on the Scratch org and developer org. The integration testing generally happens or is recommended on dev pro or partial copy. Going further down, batch data testing on partial copy or full copy, so that it actually gets to test the batch of data. On the Scratch org, the data might not be real or might be too small in size. UAT on partial and full copy. UI automation on partial and full copy, so that it mimics the end user's experience. And performance tests generally on full copy, so that it is really close to the real world scenarios of performance and load testing. Also, a side note, Salesforce being a multi-tenant system, it is generally recommended to plan performance tests in advance so that your performance or load on the system doesn't impact the other tenants. So here's the TLDR image thanks to generative AI. Where should we apply these design patterns really depends on your use case. Is your team large or small? Is it mature in testing practices? Is it near production or actually breaking that one bug found on the last Saturday? So considering these and many, many more, we should decide which design pattern should be applied where and how. You could apply all of these as you go through your software delivery lifecycle, or you could park them aside and do something else. The idea is that if we apply these, the quality of our system is not only maintained, it is enhanced as a function of time. So make wise choices, my friend, because if we don't focus on quality, a day might come when the user might not focus on us. That being said, here are a few takeaways. You can scan the QR code, which will take you to robin-gupta.com. You can also take free courses at University of Crowbar around testing and automation. You could explore the software testing Salesforce Trailhead. And last but not the least is my favorite, the book which I authored, Ultimate Selenium WebDriver for Test Automation, could be found on Amazon website and also on my publisher's website, orangeava.com. These design patterns and many more are explained in much detail in the book. It is actually written for a non-technical user to get technical. So don't worry, go get a copy. That's about it for today. You can follow Salesforce Apex Hours at Twitter and on the website. You could also find me on social media channels as @SmilingRobin on Twitter and Polymorphic Robin on LinkedIn. Thank you and have a nice day. Keep learning and take care. Bye-bye.